Hello, I'm Marcel Houngbédji. I'm lecturer at the National University of Agriculture in Benin. I'm going to present this work, Harnessing Solar Drying for Starter Culture Production in Africa. So why starter culture? Starter culture is used to optimize fermentation process. And we know that fermentation is a really popular practice in Africa in food processing. And through fermentation, we can get many food like breads, beer, yogurts, porridge, and other drink. And the thing is, in Africa, traditional technique is used, and this lead to low product quality and sometimes unsafe or non-predictable. So this means that we need improvements. And to improve, we need starter culture to optimize the fermentation process. So, starter culture is actually a formulation of microorganism which ferment the foods. And the starter culture is recommended to improve fermented food quality and safety. So, a starter culture here is a kind of ingredient that is obtained from microorganism, but this microorganism need to have metabolic activity. So so here are some examples of starter culture. This is baker yeast. We all know baker yeast. We used to bake. We can produce cake, bread with it. This is a kefir starter. This here tempeh starter culture, and this is cheese. So each group of food needs its own starter culture, because starter culture is an ingredient which provide to the food its own characteristic, So but to dry starter culture, to dry this microorganism fermentation, the conventional drying method used so far is this one, freeze drying. This is a freeze dryer. So this system use intensive energy and need high quality electricity, and is a sophisticated equipment and not adapted to African context, and you won't have a high production. So you will get finally a high production cost when you use this system. And regarding on all this system is not adapted to Africa. So this is why we think to develop a solar drying method for this. And then what we did is that we construct this locally constructed equipment dryer. You can see here the solar system here, and here is a drying chamber. The drying chamber here is divided in two. Into two, this part and this part. And this is a chimney, so when the water move from the food can go out from this. This is a compressor that is used to send drying air inside the dryer chamber. So this compressor improve the quality of the air that is going to dry the product. And this system is used to record water content, moisture content, and temperature during the drying. So this is a schematic representation. This is the compressor here, this one is here. So it sends the air inside the system, and then when the air comes here, it will be heated. So this system here, black system, allow the high extraction of solar radiation and can heat the air here, and then it send it into the compartment where the drying will occur. So so the drying processing will occur here, and these dots, black dot and green dots are probe. we cannot see them properly here, but this is a probe here, one of the probe here. So this one will help to record the data and send the data to this system. That way we get through a laptop, a screen. Yeah. So, and finally, the moisture will, the air with moisture will then put outside the system through this terminal. So this is a fan. So to like to to send the air into the product. So this is a setup during the drying. So we put the product on this tray here. We have 3 trays. We put the product on them, and then we do the drying. So basically, this is the system. Yeah. So when we use this system, we saw a very nice performance of drying of this system that we have developed. As we can see, the temperature inside the dryer increased to 60 degree, while the ambient temperature was between 30-33 degrees C. And then finally, the moisture content of the product was 9.2, while the initial moisture content was 52. And we got this water activity, which was lower than 2 and good for starter culture. Yeah. So to summarize the characteristics of the starter culture that we got, the starter culture has high microbial viability, 80 to 95%. So I have to remind that the viability is a very important criteria for starter culture, because the microorganism in the starter culture after drying must be viable, so with high metabolic activity, so that they can ferment the product, so they will help to get a very good quality of the end fermented product. And so this starter culture has high fermentation performance and can be used to inhibit pathogens. So finally, the product will be for high quality and safe for consumption. This is the starter culture that we got. So we will design a packaging, appropriate packaging for it. Yeah, here just to show some data. So thank you very much for listening, and I must thank IFS, International Foundation of Science, by providing money for this research. Thank you so much.